3.0.0 Struck by and caught in between hazards. There are no performance tasks for this section. It's a knowledge-based section. 3.1.0 Struck by hazards. On any job site, there's a risk of being struck by falling objects such as tools dropped from above, flying objects such as debris from grinding and chipping metal, and other struck by hazards. On any site where there is moving equipment or where workers are near roadways, there's also the danger of being struck by a vehicle. 3.1.1 Falling objects. Workers are at risk from falling objects when they're beneath machinery and equipment such as cranes and scaffolds, where overhead work is being performed, or where working around stacked material. To protect against struck by injuries from falling objects, always wear an approved hard hat. Employers generally require workers to wear hard hats at all times on construction sites. Remember before we were saying that if there's a red barricade, it means that there is a danger from falling objects, or they're hoisting materials overhead with a crane. When performing overhead work, use protective measures such as tow boards, debris nets, catch platforms, or canopies to catch or deflect falling objects. So if you're on a scaffold, okay, you want to use that. Do not stack materials higher than 4-to-1 ratio, height to base. Okay, that'll keep it. The shifting objects or shifting bags from falling over on people. Flying objects, 3.1.2. These are projectiles that are shot, you broke a screw or used a nail gun and it ricocheted off the board and now it's flying through the air. Chipping, grinding, brushing, or hammering are all examples of job tasks that may cause flying objects. There's a grinder. You need to wear eyeglasses, safety glasses, or safety goggles, plus a full face shield. And I never understood, why do I have to wear a full face shield if I'm wearing safety glasses, safety goggles? The full face shield protects exactly what it sounds like, your full face. Those eyeglasses, those safety glasses are not protecting your face. They're only protecting your eyes. So can I wear the full face shield and not the glasses? No. The full face shield is not impact resistant. The safety glasses are. So the safety glasses are going to protect your eyes. The face shield is going to protect your entire face. You need to wear them both. Use eye protection such as safety glasses, safety goggles, or face shields where machines or tools may cause flying particles. Inspect tools and machinery to ensure the protective guards are in place and in good condition. Make sure you're trained in the proper operation of pneumatic and powder actuated tools. Use shielding devices such as welding, screen, or similar equipment to block flying debris. Okay. Nearly 1 in 4 struck by vehicle deaths involve construction workers, more than any other occupation. So we're working by the side of the road. We've got the high visibility vests on. They've got signage. They've got barricades. And someone's going to be texting on their phone and come running up the hill and go through a barricade and send someone to meet their maker. So you got to try to take every precaution you can to protect yourself and other workers from idiots. Vehicle and roadway hazards. So the common cause of incidents for workers on large job sites and highway projects are vehicle-related hazards, such as being run over by vehicles or equipment. Big equipment come with backup alarms. If they're backing up, you'll hear the beep, 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 beep. But if you're working on a job site where you're listening to that sound all day, every day, you get numb to it. You stop paying attention. It just becomes a background noise. That often, all too often, someone will step behind a truck that's backing up and it'll back up right over them. So be very careful. You got to try to protect yourself. All right. Stay alert at all times. Keep a safe distance from vehicles and equipment. Maintain eye contact with vehicle or equipment operators to ensure that they see you. Never get into blind spots of equipment operators. Keep off equipment unless authorized. Wear reflective or high visibility vests or other suitable garments. Never stand between pieces of equipment unless they are secured. Never stand under loads handled by lifting or digging equipment or near vehicles being loaded or unloaded. You got to watch out for shifting material that's on a flatbed truck and it's tied with a banding and it's shifted. And you hop up on the flatbed truck and you break the band. What happens? The load comes and breaks your ankle. It comes and it's like an avalanche. Pretty soon you're buried in pipe. You know, watch yourself. Warning, when a vehicle is operated indoors, the carbon monoxide in its exhaust can kill or sicken anyone in the vicinity unless there's good ventilation. Carbon monoxide is especially dangerous because you cannot see, smell, or taste it. It's never a good idea to operate a vehicle, a generator, or any other machine with an internal combustion engine indoors. Make sure there's good ventilation before you operate a motorized vehicle or equipment such as generator indoors. They have battery operated forklifts, and that's what you're supposed to be using inside of a building, inside of a warehouse. Battery operated, not propane or propane accessories, tool lanyards. Tie off your tools so if you drop it, you don't smash the top of someone's head. Three point 2.0 caught in and caught between hazards. So, congested work sites, heavy equipment, and the presence of multiple trades can contribute to caught in between hazards. Primary causes of caught in between fatalities include trench excavation collapses, rotating equipment, and unguarded parts. Don't ever go near a crane. They've got an area that's roped off and you're not supposed to go in there. Don't. Because the crane, it's on a turret and the turret rotates and it makes a scissors. And if you get in between the base of the crane and the rotating turret, it'll cut you in half. I'm not joking about that. Trenches and excavations. An excavation is any man-made cut, cavity, trench, or depression formed by the removal of earth or soil. Anytime they dig. Usually a trench is described as being deeper than it is wide, up to 15 feet, and then it's just an excavation. Sometimes the term excavation and trench are used interchangeably, but there is a difference. A trench is an excavation that's deeper than it is wide, usually not wider than 15 feet. I thought I heard that somewhere. Just 2 or 3 feet of soil can put enough pressure on your lungs to prevent you from being able to breathe. As little as 4 to 6 minutes without oxygen, you can sustain considerable brain damage. So don't think, well, this trench is only 4 feet deep. I'm okay. If it caves in on you, you won't be able to inhale. Can't get a breath of air. You suffocate, you asphyxiate. Most cave-ins occur in trenches that are 5 to 15 feet deep. It happens suddenly with little or no warning. All right. I gotta be Debbie Downer here. I gotta talk to you about something. This is a trench. I hope that looks like a trench. There you go. And it's, let's say it's, I don't know, 10 feet deep. And here's your buddy. He's down here. He's working in the bottom of the trench. And this wall gives way. Let me see if I can get a different color here. There we go. I'll use purple. There. So the soil breaks loose. And you don't notice it. The walls of this trench, this moves a couple of inches. maybe just a half an inch. You don't notice when the room that you're standing in is now a half an inch or an inch narrower than it was a minute ago. You don't notice it until this whole piece falls in and buries this guy. And he's your friend, and I'm going to help my buddy because I'm a hero. And I haven't been trained in rescue and recovery, uh, but I stayed at a Marriott Inn last night, so I feel pretty confident. And you jump into the trench here, and you're down on your hands and knees, and you're digging, trying to get your buddy out, and guess what happens to this wall? It caves in on top of you. Whenever there's a cave in, there's going to be two of them. First, this wall will cave in, then this wall will cave in because of the pressure put on it by all this falling dirt. It shakes loose this other side of the trench. So you're going to see two collapses, the initial collapse and the secondary, just like you get these aftershocks. You get an earthquake and then you get an aftershock later on. That's what's happening. You jump in, now they don't have one person to rescue or recover, they've got two. They got to get your happy ass out of there before they can save your friend. So you're not doing him any favors. So don't do it. If you have not been trained in rescue recovery, don't attempt it. I know it's a harsh thing to say. He's in there, he's buried, and you feel like you're helpless and you can't do anything. If there's nobody else, then do what you got to do. Call 911, try to get fire rescue out there, something. But don't just jump in on top of it because you're just going to end up a victim yourself. You know, uh, it's the foreman's job to have all of this planned out beforehand. And there's shoring and sheeting. So what they should do is come in here and put sheets of metal in here like that. You put these long sheets of metal. These long sheets will be supported. You take some shoring and you brace. Oops, wrong color. What happened to my color? You put your shoring across here, and it holds those sheets in place so they're not going to collapse. Now you've got an area where you can work where you're safe because that wall isn't going to collapse in. You're being protected by these metal plates, long metal plates, 4 feet by 8 feet or 8 feet by 12 feet. They stick them down in the earth and then they shore them up with the boards between them. And that gives you a nice, safe area to work. You don't just dig a hole in the ground, jump in, and start working. Okay? All right. I hate to be the bearer of bad news, but that's it. Anyway, all right. Let's see here. These factors could include the following. There are certain factors that could change the surroundings of a site, making a cave-in more likely, like the weather. If it just rained, changes in weather conditions, such as freezing, thawing, or sudden heavy rains. An excavation dug in unstable or previously disturbed soil. Excessive vibration around the excavation. You're in a hole in the ground and there's a dump truck 10 feet away and it's riding back and forth. Well, guess what? It's vibrating the earth as it drives around. So it's going to cause a cave in. Water accumulation in an excavation. Sometimes there are visible warning signs around the excavation that can be spotted before a cave in occurs. Being aware of the warning signs increases your chances of getting out before collapse occurs. If you see fissures and they're running parallel with the trench, 5, 6, 8 inches away, or 12 inches away, or 15 inches away, but they're fissures and they're running parallel with that trench, don't get in that trench. That's the side of the trench giving way. It's getting ready to cave in. So, and it's not always visible. You go and you think it's a happy day, and you get down to the trench, and the next thing it becomes your grave. Be careful. Be careful. Soil type is a key factor in determining the type of protective system needed to ensure that the trench will be safe. Solid rock is the most stable, while sandy soil is the least stable. So if you got solid rock like granite, like they carved Mount Rushmore, you dig a hole in that, you can live in it. You can make a cave for yourself. It's not going anywhere. Excavation walls stay vertical as long as the excavation is open. Type A soil uh, is fine-grained, cohesive clay, hard pan, and caliche. Particles are too small to see with the naked eye. You can make a ball out of it like a snowball, and it'll stay together. It's like clay. That's type A soil. Type B is angular rock silt, similar soil. There will be shifting, but it has a little bit of stability. Type C is like beach sand. Coarse grained granular sand, gravel, loamy sand, particles are visible to the naked eye. It's very hard to make a trench at the beach. You know, when you get down to the wet soil at the beach, then you're talking about type A soil or type B. But if you've got dry sand at the beach, you've seen it. You can't build a sandcastle with dry sand. It doesn't work. To be safe, treat soil as if it's type C soil, unless proven otherwise. If you don't know, pretend it's type C. There's that word again, competent. A competent person, someone who has knowledge of the hazards, how to correct them, and the authority to take corrective measures. That word and the authority to take corrective measures. That's a competent person. Must inspect excavations daily and decide whether cave-ins or failures of protective systems could occur. Benching. So you can dig a trench, you can dig the walls as straight as you can try to do it, but benching systems cannot be used with type C soil. So here's type A soil, and you can bench that type A soil. You're still using this no more than I think 60 degrees or something. Yeah, or yeah, what does it say here? Rise over run, 45 degrees. Your rise over run is 1/1. So for no more than 45-degree angle in type A soil, and you're allowed to bench it. Type B soil, did they give us type B? They didn't give us type B. It's more like a 30-degree. See, I thought type A was 60. I thought it was 60 degrees. I thought type B was 45 and type C was about a 30-degree. Type C is a very shallow trench. It's more that you've taken all the dirt away. You're going to put whatever you need to put down there, and then you're just going to bury it back. There's a lot of sand, a lot of earth to be moved if it's type C. Trenches are often located in narrow places, so sloping and benching are not options. In these situations, support systems like shoring and shielding must be used. A structure used to protect workers in trenches is shielding. Shoring, a support system designed to prevent a trench or excavation cave-in. All right, shoring and shielding. Or you can use a trench box. This is called a trench box. So you dig your trench and you put this trench box in there, and then the workers can work inside of it. Shielding structures, also known as trench boxes, are placed inside trenches or excavations and are strong enough to protect workers in the event of a cave-in, so long as the workers are within the confines of the box. So here's a nice little place in here. Here's your trench box, and you can work inside here, and you're safe. Everything's good. Cave-in fatalities. Each year in the United States, more than 100 people are killed, and many more are seriously injured in cave-in accidents. The chances of a trapped worker being killed can be as high as 50%. I saw a guy, it was a shallow, shallow trench. I mean, it was about 3 feet deep. I'm telling you, I'm not kidding. It was a shallow trench. And this guy was tall. And He was in the trench when the side started coming, and he tried to get out. One leg got out of the trench, the other leg got pinned in there. And so we, you know, had to try to help him out. And there was a backhoe operator. He used the bucket of the backhoe to try to just nudge there was a kind of a big solid piece. It wasn't a rock per se, but it was holding together. So he took his bucket and he tried to move that out of the way, and then the guy finally got his leg out. And you think, oh, well, that's great. Nothing happened to him. Yeah, it messed him up. It messed up his knee because his knee was pinned in there, and that heavy soil pushed his knee. And yeah, he was limping for a couple of weeks. I'm telling you what. So don't think, oh, 3 feet, that's nothing. You can still get hurt. The spoil is the part of the earth that they took out of the hole. You dig the hole and you got the sand, you got to put it somewhere. They say put it at least 2 feet away from the edge of the trench. I say put it 4, put it 5. Swing that bucket as far away as you can. Dump it as far away from that as you can. Materials such as earth removed while digging a trench or excavation, that's the spoil. Spoil piles comprised of the material removed from an excavation and other materials represent a hazard if not handled properly. Loose rock, soil, materials, and equipment on the face or near an excavation can fall or roll into the excavation or overload as possible collapse and possibly collapse the excavation walls. You got to watch out with trucks. People will drive a truck and they'll drive right up to the edge of a trench thinking, like, there's the ground. I can see the ground. The ground is right there. And they pull right up, and then the side of the trench gives way, and the truck rolls over. And now the truck is down in the trench. So stay away from an excavation. Don't get near it. Keep all spoil materials and heavy equipment at least 2 feet away. Like I say 4. Get it as far away as you can. Or set up barricades to contain falling material. Again, there's a lot of good information in here. Read it on your own. I'm not going to read the whole book to you. I've already read half the book anyway. But let's see, call before you dig. Okay. 3.2.2, tool, machine, and equipment guards. Don't remove guards. Don't use a tool that has a missing guard. Almost all tools, machines used in construction and in industrial work are equipped with guards that protect workers from rotating parts. Figure 42 shows the guards on a grinding machine. All tools and machines that could harm workers must have a guard shielding the hazard. The following types of tools and machines must have guards. Grinders, bench grinders, you gotta have guards. These are clear plastic, you can see through them so you can see what you're doing, but you still have to have that guard to protect you. Grinding tools, shearing tools, presses, punches, cutting tools, rolling machines. Tools or machines with pinch points, tools or machines with sharp edges. I'm going to try to go faster here. There's a guard. See the guard? There you go. There's a coupling guard. It's in place so that rotating machinery, you won't get caught in it. You don't want to get caught in it. Cranes and heavy equipment. I know this section is covering a lot of material. I have to say that this section is it's the OSHA 10-hour program, basically, is what it is. Your instructor will probably get you access to OSHA online, or they'll be teaching you OSHA. If you're doing OSHA, do this section at the same time. It's all the same information. You'll pass the test with flying colors, and you'll get your OSHA 10-hour card. I'm not saying if you do this module, you'll get an OSHA card, but I'm saying they're the same information. That's why they're going into cranes and heavy equipment. All right. Motorized equipment is used in many different jobs, including construction, mining, plant maintenance and operations, road maintenance, equipment transportation, and snow removal. Not here in Florida, but anyway. Working with motorized equipment can be dangerous. Workers can be crushed by falling loads, fall from equipment, electrocuted by power lines, or or be struck or trapped by vehicles. Oh, they're talking about the swing radius, excuse me. The swing radius of equipment can also be a hazard if the job is not carefully planned and properly barricaded. Most heavy equipment has pinch points. So here are your pinch points. This turret rotates, and if you walk up here because you want to talk to this guy and he doesn't see you, he could swing this turret around and he could cut you in half. So don't go near it. Make sure you make eye contact with him before you get anywhere near him. Look at this guy. He's standing next to the wall, and here the crane moves, and guess what? Boom. He gets pinched. This is your caught in between hazard. This is your caught in between hazard. Okay. Which of these activities is most likely to produce flying objects? I'd say using a chipping hammer. Type of soil most likely to result in a trench cave-in is type C. Okay, let's 4.0.0 or 0, I guess. Energy release hazards. Now, energy is pneumatic, hydraulic, electrical, steam, pressure, gravity. All of these are sources of energy. So don't think that electrical is the only one. Once equipment is de-energized, lockout, tag-out devices must be attached to all sources to prevent someone from unknowingly restoring the energy before the work has been completed. Lockout, tag-out, a formal procedure for taking equipment out of service and ensuring that it cannot be operated until a qualified person has removed the lock and or warning tag. So there's a whole procedure. There's a whole written manual on how you're going to do it. It's a 7-step procedure. You don't just turn it off and lock it out and you're good to go. You check it with a meter to make sure it's live. Then you check the meter on another live circuit to make sure it's still working. Then you turn off that circuit. Go check it with the meter and make sure that it's dead. Check the meter again on a known live circuit to make sure that the meter is still working. I know it sounds ridiculous, but the meter was just working a second ago and you check it, somebody turns off a circuit breaker, you check it and it's dead. Maybe something came loose inside of that meter. Maybe the battery just gave up the ghost. The batteries just went dead. Who knows? Maybe you set it down and then you picked up the wrong one and it doesn't have working battery and it tells you that everything's a-okay and it's not. So after you check it and it's dead, you have to recheck that meter on a known live circuit. They call it a live dead live test. You check it, it's live. You check it, it's dead. You check the meter on another known live circuit to make sure the meter's still okay. Like I say, there's like 7 steps to doing this. You don't just turn it off and put a tag on it. Electrical safety guidelines. There are different types of electrical incidents. Any of the following can happen. You can get burns, electric shock, explosions, falls caused by electric shock, or fires. The human body comes in contact with an electrically energized conductor, and it's also in contact with the ground at the same time. The body becomes an additional path of resistance for the electrical current to flow through. You might be the only path for current to flow through, and you'll get real hurt, real bad. Ground is the conducting connection between the electrical equipment or an electrical circuit and the earth, or something taking the place of the earth, like a metal pipe. Something that is allowing electricity to get back to ground, to earth. When we talk about ground, we mean the ground we stand on. Some people call it an earth ground. It's a ground. Okay. So these are the effects of electrical current on the human body at 0.001 amps. That's 1 milliamp. You might feel a faint tingle. I don't think I feel a tingle till about 4 milliamps, but at 4 to 5 milliamps, you'll feel a slight shock. 6 to 25 milliamps, it'll be painful. You'll get a painful shock. Muscular control is lost. There's a point at which it's called the let go threshold. And it might be 18 milliamps, it might be 20 milliamps. It's different with different people, depending on how calloused your hands are, depending on how dry you are. If you're real sweaty, then that let go threshold might only be 15 milliamps. But there's going to come a point where our nervous system works on electricity. We use about 8 milliamps to communicate with our bodies, and we can open and close our hands. So if you have greater than about 15 milliamps and you're gripping a hot wire and your brain is saying, let go, let go, let go, your hand is listening to the 15 milliamps that's telling them, hold on tight, and you can't let go. That's the let go threshold. Once you get above the let go threshold, you can't let go. You can't open the palm of your hand. It's very dangerous. There's a lot of confusion as to how much electricity can actually kill you. And there are some reference materials that say as little as 300 milliamps. There are some that say as little as 75 milliamps. There are some that say as little as 50 milliamps. I go with the 50 milliamps. But another reference material said if it's above your let go threshold, if it's 18 milliamps and you can't let go, you might sit there and fry. It might take a while, but it'll kill you. So who knows what the smallest amount of current is? That's why this book never says this is definitely going to kill you. It says death is a possibility. And then when you get up to higher and higher amps, they say it's probable, almost likely. They never say you're definitely going to die if you get this much amperage because they don't know. Different people are different. So this 6 to 25 milliamps, a Christmas tree light bulb, it's a painful shock, muscular control might be lost. You're probably over your let go threshold. And here, 50 to 900 milliamps is extreme pain. Breathing stops, severe muscular contractions occur, death may result. They didn't say positively. 1 to 10 amps, 1 to 9.9 amps, ventricular fibrillation and nerve damage occurs, death may result. Above 10 amps, the heart stops, you have severe burns, and death may result. You might survive it. You probably wish you hadn't, but you might survive it. Warning, less than 1 amp of electrical current can kill. Always take precautions when working around electricity. Grounding 4.1.1. Grounding is a method of protecting humans from electrical shock. However, it's normally a secondary protective measure. The term ground refers to a conductive body, usually the earth. Ground is conductive connection, whether intentional or incidental, by which an electric current or equipment or circuit or equipment is connected to earth or to an engineered grounding system. By grounding a tool or electrical system, a low resistance path to earth is intentionally created. When properly done, this path offers low resistance and has enough current carrying capacity to prevent the buildup of voltages that could create personnel hazard. Tools can be double insulated. You can have the 3 prongs that has a grounding prong on your electric cord, or you can use tools that are double insulated. Double insulated tools are also very effective in preventing shocks. They'll only have 2 prongs on their plug, a hot and a neutral. but they're isolated with this double insulation. So it's like they took a drill motor and they wrapped it inside of another shell of plastic. So you can't touch anything metal on the drill motor. So it's double insulated. All right. There's the grounding conductor. There's the third prong. That's the one that'll save your life. That's the mouth and the face here. This one is double insulated. Look, it has a square inside of a square. That's the universal, well, I shouldn't say universal, but that's what we use here in the United States and Canada for double insulated tools. They'll put a square inside of a square. And look, the two-prong plug. So if you see a tool with a two-prong plug, and you go, that's not to code. It has to have a ground. No, it doesn't. Not if it's double insulated. So this says model 444, it's 120 volt amp, it's double insulated. It says it in plain English, double insulated. And it also has the symbol for double insulated. All right. Ground fault circuit interrupters, 4.1.2. A ground fault circuit interrupter is a fast-acting circuit breaker that senses small imbalances in the circuit caused by current leakage to ground. A ground fault circuit interrupter continually matches the amount of current going to an electrical device against the amount of current returning from the device. Whenever the two values differ by more than 5 milliamps, the GFCI interrupts the electric power within 1/40th of a second, about a cycle and a half. So this is a device that interrupts the de-energizes an electrical circuit to protect a person from electrocution. Also a circuit breaker designed to protect people from electric shock and to protect equipment from damage by interrupting the flow of electricity if a circuit fault does occur. Here's a GFCI pigtail. You've got test and reset, just like in your bathroom, the GFCI. Basically what this GFCI does, exactly what they were talking about. It measures the amount of current in both the hot and the neutral. And if the two are the same, the GFCI is happy. So if you get between the hot and the neutral on the load side of a GFCI circuit breaker, it won't trip. You'll get hurt. If you go between hot and ground, then it'll trip. Because if there's a difference of even between 4 and 6 1,000ths of an amp, 4 to 6 milliamps will trip that GFCI. They say 5 milliamps plus or minus 1 milliamp. So. Summary of electrical safety guidelines. Yeah, these films. If you're on Pearson, watch these videos. They're good. All power tools used in construction should be ground fault protected. Make sure that panels, switches, outlets, and plugs are grounded. Never use bare electrical wire. Never use metal ladders near any source of electricity. Inspect electrical power tools before you use them. Never operate any piece of electrical equipment that has a danger tag or lockout device attached to it. Never use worn or frayed cables. If the cord is frayed or worn, disconnect the power and dispose of the cord. Yeah, don't use something that looks like this. That cord has been damaged. All right. 4.1.4, working near energized electrical equipment. They call it proximity work. You're not working on the circuit, but you're working near the circuit. Work done near a hazard, but not actually in contact with it. One of the examples that they gave was a worker working near a steam line. The steam line is very hot. They're not working on it, but they're working near it. They have to make sure that they keep their wits about them, that they don't try to lean up against it with the palm of their hand, because they'll burn themselves. So, no matter what your trade, your job may include working near exposed electrical equipment or conductors. This is one example of proximity work. Often electrical distribution panels, switch enclosures, and other equipment must be left open during construction. This leaves the wires and components in them exposed. If you are not studying to be an electrician, if you're some other trade, Don't go near the electrical panels. If you have a question, if you need something, find an electrician. Ask them. Don't go near it. Okay. If someone is shocked, call 911. Try to give them CPR, but you need an AED, an automatic external defibrillator. If you're there when someone gets an electrical shock, you can save a life by taking immediate action. The best thing to do is to immediately shut off the power to the circuit. Do not touch the victim while he or she remains in contact with the power source, because then you'll get hurt. Once the circuit's disconnected, call an ambulance or the emergency number at your job site. Render first aid only if you're trained to do so. Do not touch the victim or the electrical source with your hand, foot, or any other part of your body, or with any object or material. You could become part of the circuit. If you see someone and they're actually being shocked and they can't get away, or if they've passed out and there's still an electric line on them, and you suspect that they're still being shocked, get a wood 2x4 or a fiberglass ladder, or get a length of rope. I know that sounds crazy, but take the length of rope and try to just throw it over them and pull them away from that electrical line. Get them off of that circuit. You could save a life. You got to get them away from the source of electricity. Okay.